Hi, my name is Reina Ishibashi, and today I'm here to share 6 effective ways to implement coding in a math class. There's been some research done in this area. The Office of Educational Technology states that technology provides students with multiple means of representation so that students can approach information in more than one way. If there's a way that we can implement technology in a math class such that we can represent math differently, there's a chance that we can have students better understand the math as well, because because we're approaching math from a different direction than we usually do. So the 6 effective methods that I'll be sharing today include building visuals, working in group settings, focusing on active engagement, relating the content back to math, providing teacher-generated code, and providing flow. The first method that I want to share is building visuals. This is something that I came across during an opportunity that I had co-teaching a single variable math class at Carroll College during the fall 2019 semester. This class had a 75-minute lab twice a week where I was assisting as a teaching assistant for 25 students. Once a week, students worked on one lab with their lab partner, and I had the opportunity to give feedback for these labs as well. Many of these labs required students to create graphics for the unit that they were learning during the lecture portion of this class. So some of these graphics included making figures for summations and limits and finding slopes. So students took turns coding and produced different visuals every week. This particular example that I have on the slide is from the summation unit, where students showed graphically what the trapezoid sum was doing and what the midpoint sum was doing. After students completed this lab, I had them provide feedback for me on a survey. And these are some of the responses that I received. So one of the students said, I gained a better understanding of the error across different approximation methods, as well as the mechanics behind what trapezoidal and midpoint approximation are doing. Another student mentioned, it made me understand the trapezoid method better. These responses indicate that creating these visuals helped them understand what they were learning in their math class in a more visual format. So by creating these visuals, they were able to better understand what they were learning during their math lectures. Another example that I have is one where students were trying to find the area between two curves, and I also have sample code on the left side as well for anyone that is interested. So this code over here produces the graph on the right, and this is written using MATLAB. So in this case, students were expected to be able to draw two functions on a graph, so the red and the blue function, and then find the intersecting points, and then integrate using the integral method on MATLAB. The second method is working in group settings. This provides a collaborative learning experience for the students where they can work towards a common goal and help each other out and ask questions in class. This works well in an inverted classroom. An inverted classroom is where students watch a version of the lecture content online and come to work on problems in an interactive and collaborative setting inside the classroom. So this puts the focus of the students' learning on the students themselves, so they're more active about learning, and it puts the responsibility on them. Another way to have a group setting environment is to set aside specific time to work together in groups. So during my previous example, working with the single variable calculus classroom at Carroll, that class met twice a week on Tuesdays and Thursdays, and that was specifically set aside for lab. So this was not a time where students learned new material, but it was a time where students worked together in groups or in pairs to work on their labs. The third method is active engagement. So, inverted classes and setting aside specific time for coding helps with actively engaging the students. But you want to make sure that everyone is actually interested in coding and is actively involved, and no one is just sitting to the side. So, a researcher named Nice was doing a study where student teachers were implementing programming in their class. And Diane was a student teacher in a math classroom, and she was implementing coding in her math class, but she found that some students were relying too much on others. So, some students would be working very hard and they were actively engaged, but then there'd be other students who were just sitting to the side and just passively observing the other students working. And this is not an ideal situation because then the passive learner is not necessarily getting the most out of the experience. So you want to make sure that everyone is actively engaged and everyone is involved in the task that is supposed to be done in the class. The fourth method is relevance to mathematics. So once again, um, because you're implementing technology in a math classroom, you still want to emphasize the mathematics. So it's important to explicitly state how the programming activity that they're doing is relevant to the current math unit that they're doing. This is an issue that Diane, once again, the student teacher in Nice's study, found as an issue. She had multiple students asking why they were programming in the first place. So it's important to always tie it back to the bigger picture and to mathematics. The fifth method is using teacher-generated code. So, a study done by Cole found that there were two categories when understanding coding. This was code comprehension and code syntax. So, code comprehension is when you look at a piece of code and you're able to understand what is being done in that piece of code. Whereas code syntax is when you're writing out the code and how you type it out. So it's a matter of being able to read and interpret code and then write your own code. To be a strong coder, it's important to focus on both of these areas. But once again, because we're implementing coding in a math classroom, we don't necessarily need to be experts on programming. We just need to be able to code just enough so that we can tie it back to our mathematics. So one thing that another researcher named Carroll found was that there was more understanding when students were given short pieces of code rather than creating their own code. So it's okay for teachers to provide some pieces of code to their students so that they can use it when they're trying to do whatever it is to tie it back to the math content. Carroll also found that math and algorithm scores correlated highly with programming tests as well. The last method that I'll be sharing is flow. So flow is something that was defined by Mihai Csikszentmihalyi, and he defines it as when students are fully engaged in a task and when they're getting the optimal experience out of it. So another researcher named Talbert mentions that inverted classrooms actually produces this type of flow because it switches the students from learning passively to learning actively. Once again, because it puts the responsibility of learning on the students themselves. Talbert also found that this type of inverted classroom increased the students' coding ability, critical thinking, and math skills as well. Csikszentmihalyi also states that challenging activities provides flow as well. So the intrinsic motivation that students feel to work on the task, as well as the self-efficacy they feel once they complete that task, lends itself to feeling the flow. For future teachers, these are some of the recommendations that I have. The first is either providing coding quizzes or switching who is coding. This goes back to the active engagement. So if you let the students know that you will be having coding quizzes, it puts the responsibility of learning the coding on the students. So it kind of forces them to be actively engaged in the class when they are supposed to be coding. This works also by switching who is coding as well. So instead of having one person code all the time, if you have students switch up who is coding, then it helps to make each of the students in the class actively engaged. The second piece of advice that I have is creating tasks that produce visuals. So in a math classroom, that could be creating plots, graphs, or animations, but anything where students are able to see something visually after completing the coding task will help the students understand the math better, because these visuals are sometimes harder to see in a lecture type of classroom. The last advice that I have is emphasizing the mathematics. Once again, this is just implementing coding in a math classroom, so the coding doesn't necessarily need to be very hard or challenging, but it just has to assist the students in learning the math. So once again, tying the content back to mathematics and emphasizing why students are doing the coding task and how it's going to help them with their learning would be best. And these are my sources. Thank you so much.